Well, we're ready to start chapter 4. And chapter 4, we're going to start all about triangles. So our first section is the angles in triangles. So welcome to section 4.1. There are two different ways we can classify triangles, put them into groups. One of that is by looking at their angles. The other way we can group them is by looking at their sides. So we'll take one at a time. We'll start with the three different classifications based on angles. And what we look at is the largest angle in the triangle. If the largest angle in the triangle is less than 90 degrees, then we say this is an acute triangle, because all three angles will be acute, less than 90. If our largest angle is exactly 90 degrees, then it's a right triangle. And if the largest angle is greater than 90 degrees, it is an obtuse triangle. If our triangle is a right triangle, then we can further look at different parts of it. Here is a right triangle. Notice the two sides that the right angle creates are called the legs. The side opposite the right angle is called the hypotenuse. That comes from Greek. So that's the sides of a right triangle. Also, the sides have this relationship, which we know as the Pythagorean theorem. If you take one leg and you build a square off it, and the other leg and build a square off it, all the material used to make those two squares will be exactly the amount you need to make a square off the hypotenuse. So that means one leg squared plus the other leg squared equals the hypotenuse squared. You're used to seeing it labeled A, B, and C. Just realize the A and the B refer to the legs. One leg squared plus the other leg squared equals the hypotenuse squared. The other way we can classify triangles is by comparing their sides. If all three sides of a triangle are different lengths, then we say it is a scalene triangle. If two of the sides are the same length, exactly the same, it is an isosceles triangle. And if all three sides are the exact same length, then it is an equilateral triangle. So when we classify triangles, we can give them two names, one based on the measure of the angles and the other on the lengths of the sides. If we have an isosceles triangle, the two sides that are congruent are called the legs. And the angle there that creates the legs, or that connects the two legs, is called the vertex angle. The third side that's different is called the base, and the two angles on the end of the base are the base angles. So it's important to know what parts of the triangle you're talking about when you are talking about isosceles triangles. If you have an equilateral triangle, all three sides are the same, notice automatically all three angles will also be the same. Okay, we have a new theorem for your notebook. This is the triangle angle sum theorem, which I think you already know, but it's very, very important, which basically says the sum of the measures in any triangle is 180 degrees. If you add the three angles of any triangle, I don't care what shape it is, they will always add up to be exactly 180 degrees. There are a couple different proofs in your text about why that's the case, which I won't walk through, but I will just let you know, don't forget, the angles always add up to be 180 degrees. Okay, a corollary to that triangle sum theorem related to it is this one. If I have a right triangle, then the two acute angles are going to be complementary. Well, that just makes sense, because if all three add up to be 180 and a right triangle is exactly 90, if I subtract that 90 from the 180, I'm left with 90. So these two angles will always add up to be 90. That's really helpful to remember, because often when people are trying to find these angles, they'll go 180 and they'll subtract 90 and they'll subtract this, but it's so much easier to just look at these two angles and know they're going to add up to be 90 degrees. Another corollary to the triangle sum theorem, it has to do with equilateral triangles. Because all three sides are the same, all three angles are also the same in an equilateral triangle. Since they're all the same and they have to add up to 180, then if I take 180 and divide it by 3, each one is exactly 60 degrees. That's another corollary to the triangle sum. The measure of each angle in an equilateral triangle is 60 degrees. Here's an example of the kind of problem that you guys can get and you'll have to solve using this triangle sum theorem, the fact that all three add up to be 180. If you're given this diagram, can you figure out what is the measure of angle 1, what is the measure of angle 2, and what is the measure of angle 3? Remember, when you look at these, you really are seeing three triangles. We have this triangle here, this triangle here, and also the large angle here. Also, this angle, the large angle, could be 60 plus 45 together. So those give you different approaches to solving this problem. There isn't any one right way. There are different options. But since I wrote the measure of angle 1 first, let's find the measure of angle 1 first. And angle 1 is the third measure in this triangle here. So what I need to do then is, if this one is 60 and this one is 36, then I just take and they have to add up to 180. So I'll write it out. 60 plus 36 plus angle 1 equals 180. So if I combine these, and I subtract my 96, I'm just showing you every step, then the measure of angle 1 is whatever 180 minus 96 is, which I believe should be 84. So the measure of angle 1 is 84 degrees. Now I have a measure of angle 2. What approach could I use to find the measure of angle 2? I could realize that angle 1 and angle 2 are a linear pair. They form a straight angle. Therefore, they have to be supplementary. They have to add up to be 180. So if angle 1 is 84, then angle 2 must be 96, because 84 plus 96 is 180. Now, knowing that helps me to find the measure of angle 3, because now I can use this small triangle, and I know that 45 plus 96 plus 3 plus angle 3 has to equal 180 degrees. So I can take the time to write that equation if I want to. Or I can take my calculator and go 180 minus 96 minus 45 equals, and I'll have my answer. Algebraically, measure of angle 3 has to equal 39 degrees, and I have my three angles. I could have found the measure of angle 3 by realizing this angle is 105, so 36 plus 105 plus angle 3 also equals 180. That would also work. It'll give me the exact same answer. Math is so consistent. Another theorem for your notebook is what I've always heard of as the third angles theorem. The shorthand for this, if I have two angles, then that implies the third angle. Basically says if two angles of a triangle are congruent to two angles of another triangle, then the third, I should have written third, then the third angles are also congruent. Why? Because they add up to 180. So if the first two are the same, in order for them to both equal 180, the third angle also has to be congruent. That's the third angles theorem, and that will help you to solve some other problems as well. There's a step-by-step proof of why this theorem is true in your book if you want to look at it, but just know, based on this diagram, angle C would have to be congruent to angle Z. if I extend the side of any triangle, like I did here, you see I've created a linear pair. This is another angle here, which is outside of my triangle. We call that an exterior angle. So an exterior angle is the angle that forms a linear pair with any angle inside of a triangle. That's an exterior angle. There are special relationships exterior angles have. That's why you need to know what one is. If this is the exterior angle, then 4 and 5 here would be the remote interior angles. So those are the other angles that do not form the linear pair with this exterior angle. You need to know that for the next theorem I'm going to show you. Okay, so the exterior angle theorem states that the measure of this exterior angle is equal to the sum of the two remote interior angles, which may seem weird, but when you think about it, that makes perfect sense. Because I know if I add angle 2 to angle 1, I get 180 degrees because they're a linear pair. If I add 4 and 5 together to angle 1, I get 180 degrees because it's the sum of the interior angles of the triangle. So if these 2 plus 1 is 180, and this exterior angle plus 1 is 180, this angle has to be the same as those two added together. That's why the exterior angle theorem works. Okay, here's an example of the kind of problem that you can get. And yeah, these are not just simple numbers. And so that you're looking at this may overwhelm you, but just stop, back up and think about what you know. We know that the exterior angle is equal to the sum of these two remote interior angles. So I'm going to use that knowledge to set up an equation. This angle, which is 13x minus 5, is equal to these two angles added together, which is 5x plus 3 plus 64. Now I'm going to use that. Now that I have an equation, I can solve for x. So here I combined like terms. I put my x's together here, subtracted 5x. I added my 5 to get 8x equals 72. And then I found that dividing by 8, x equals 9. Now that I know what x is, now I can plug it in to answer this question. The measure of angle W is 5 times 9 plus 3, or 48 degrees. And the measure of angle XYZ is 13 times 9 minus 5, which is 112. And now how can we check? If we're right, then 48 plus 64 should equal 112, and it does. So we've solved it. Okay, I really want you to try this before we end this video. Here's a problem, and I want you to find all 4 angle measures. So notice this is, I have triangle LMN, and I have this exterior angle, LNO. The exterior angle is equal to x. L is x minus 60, just in case you can't read my board, and M is x minus 20. I want you to try to find this exterior angle, O in L, the measure of angle L, the measure of angle M, and also this other interior angle, angle L in M. Pause the video, work through it, and see if you get the right answer. Then restart it and I'll walk through, and that way you can check and make sure, check your understanding and see how well you did. So pause the video and work that through. Okay, so hopefully if you tried to find this one first, O and L, you realize that exterior angle X is equal to these two added together, which is x minus 60 plus x minus 20. So when you simplify that, you got 2x minus 80. And when you subtracted 2x, you got negative x equals negative 80, which means x equals 80. So that gives you that exterior angle of 80 degrees. So how did you do with that? Once you know that x is 80, then L is 80 minus 60, or 20, and M is 80 minus 20, or 60, and then these three have to add up to 180, so this angle is 100. How did you do? I hope you did well. That was one of your homework problems, so that gives you an idea of what your homework assignment will look like. And so work this through, and I'll see you guys next time. That's it for now.